Dear students, in this video we are going to discuss about indirect method of FM generation. It is also called as Armstrong method. Before going to discuss about indirect method, we should know the drawbacks of direct method. In direct method, LC oscillators are normally used. These LC oscillators are unstable, so broadcasting of FM signal is difficult. The second drawback is the generated FM signal has some distortions. So we go for indirect method of FM generation. In the case of indirect method, crystal oscillators are used to generate the carrier. Second is the PM signal is used to generate the FM signal. So this method is called as indirect method because the PM signal is used to generate the FM signal. Now we are going to prove mathematically how the FM signal is generated from the PM signal. First one is the general equation of PM signal and the second one is general equation for the FM signal. If you compare these two equations, except this Kp and Kf, you have only a single difference that in the PM equation you can apply the message signal, modulating signal directly, but in the case of FM signal you should integrate the modulating signal before applying to the phase modulator. So if I use integration in this term, it becomes a equation of FM. This is the basic concept behind the generation of FM from the PM. Let us consider these two diagrams. The first diagram depicts that generation of PM. In the generation of PM, the modulating signal is directly given to the phase modulator along with the crystal oscillator. Then the output of the phase modulator will be the PM signal. But in the case of the second diagram, where the FM signal is generated with the help of the PM signal. Here the modulating signal is not given directly to the phase modulator, but in between the modulating signal and the phase modulator we have an integrator. The integrator is achieved with the help of the elements resistor and capacitor. It is also called as RC filter. RC filter. This output of the filter is given to the phase modulator along with the crystal oscillator. Then the output of the phase modulator will be the FM signal, but the output has less frequency, so it is called as narrow band frequency modulated signal, NBFM. This block diagram shows the basic operation of phase modulator. In this, the crystal oscillator produces the stable unmodulated carrier signal, and this stable unmodulated carrier signal is applied to the 90 degree phase shifter, minus 90 degree phase shifter along with the or through the buffer, and also the same carrier is applied to the combining network, all these through the buffer. The output of the minus 90 degree phase shifter will be the minus 90 degree phase shifted carrier with respect to the original carrier. This minus 90 degree phase shifted carrier is applied to the balanced modulator along with the modulating signal. The output of the balanced modulator and the original carrier are combined using the combining network. Now the output will be the narrow band PM signal because I am directly applying the modulating signal to the balanced modulator. If you need FM signal here, then you should use an integrator before applying the balanced modulator. Before applying the modulating signal to the balanced modulator, you should include a integrator to get the narrow band FM signal. So this is the basic diagram which is used for both phase modulated signal and frequency modulated signal. The simple difference is if you apply the modulating signal directly to the balanced modulator, then you get narrow band PM signal. If you use integrator between the balanced modulator and the modulating signal, then the output will be narrow band FM signal. Now we are going to see the phasor diagram of signal at every position of the phase modulator. So listen carefully. At the points 1, 2, 3, we have the unmodulated carrier, the same carrier which provided by the crystal oscillator. We will represent like a vertical line. At the point 4, we have minus 90 degree phase shifted carrier that can be represented in a phasor diagram. That is minus 90 degree shifted carrier. Now we will consider the position 5. That is the output of the balanced modulator is position 5. The output of the balanced modulator will be DSB-SC, that is double sideband suppressed carrier. Here the carrier is suppressed and two sidebands are represented as USB, upper sideband and lower sideband, and the resultant of the sideband is indicated by this line. Now let us consider the overall block diagram of indirect method of FM generation or Armstrong method. In this block diagram we have two main blocks. One is called as phase modulator block and another one is called as multipliers and amplifiers block. In the phase modulator block, first we start from the crystal oscillator. The output of the crystal oscillator is the carrier, that is unmodulated and stable carrier, which is given to the buffer. Output of the buffer is also the same carrier which is given to the combining network, and the carrier is also given to the 90 degree phase shifter through the same buffer. The 90 degree phase shifter shift the phase of the carrier by 90 degree. So the output is the phase shifted carrier, 90 degree phase shifted carrier, and it is applied to the balanced modulator. The output of the balanced modulator and output of the buffer, that is the same carrier, is combined with the help of combining network. As we know, the balanced modulator produces DSB-SC signal, that is double sideband suppressed carrier. The carriers are suppressed, so we have only the sidebands, double sidebands. One is USB and another one is LSB. Both are combined with the help of combining network. The balanced modulator will get the input from 90 degree phase shifter and the audio equalizer. If you are directly applying the modulating signal to the balanced modulator, then the output of the combining network will be PM. But here we have audio equalizer before applying into the balanced modulator. The modulating signal is applied to the balanced modulator through the audio equalizer. This audio equalizer is nothing but the RC filter, that is the low pass filter. It is also called as integrator. Since the modulating signal is integrated and then given to the balanced modulator, then the output will be frequency modulated signal, that is NBFM. But the output of the combining network, that is the FM signal, has very less frequencies, very low frequency. So the frequency can be increased with the help of this multiplier and amplifier circuit. First, the narrowband frequency modulated signal is applied to the group of multipliers, where the multipliers increases the frequency by 2 times or 3 times or 4 times. It may be a doubler or it may be a tripler, etc. The group of multipliers increases the frequency of narrowband frequency modulated signal, and it is applied to the mixer through the local oscillator. Now the mixer mixes both the frequencies, output of this group of multipliers and the output of this local oscillator frequencies. The output of the mixer has two components. If you consider the group of output of the group of multipliers is 1000 Hz and local oscillator frequency is 200 Hz, then the output of the mixer will be 1000 plus 200 Hz or 1000 minus 200 Hz. So you will get either 1200 Hz and 800 Hz. Again, this output is given to the group of multipliers. If required, its frequency is further increased with the help of this group of multipliers block. Already we have increased the frequencies with the help of group of multipliers. After the mixing also we can increase the frequency of the resultant signal with the help of group of multipliers. Finally, the output of the group of multipliers is given to the Class C power amplifier, where the power level is raised to the desired level with the help of Class C power amplifier. Now we can see the derivation for the generation of FM signal. For that I am considering the carrier signal. Carrier signal Vc of t is equal to Vc cos omega ct. Modulating signal Vm of t equal to Vm sin omega mt. We have 90 degree phase shifter, so output of the phase shifter will be Vc of t is equal to Vc cos, this is phase shifted by 90 degree, so we can write Vc of omega ct minus 90 degree, which is equal to Vc sin omega ct, because we have the formula cos theta minus 90 is equal to sin theta. So cos omega ct minus 90 can be written as sin omega ct. This is Vc of t. Now we can find the output of balanced modulator. From the block diagram we can say that the input of the balanced modulator will be one from the phase shifter and another one from the modulating signal. As we already know, the output of the balanced modulator will be a DSB SE signal, that is double sideband suppressed carrier. This double sideband suppressed carrier equation can be obtained by multiplying the carrier signal with the modulating signal. So you will get Vc sin omega ct into Vm sin omega mt. We should note that Vc sin omega ct is the output of the phase shifter, 90 degree phase shifter. In the next step you will get Vm into Vc into sin omega ct sin omega mt. From the diagram we know that the output of the combining network will be the resultant FM signal, resultant narrowband FM signal, that can be obtained by taking the difference between carrier signal and the DSB SC signal. This one comes from the buffer and this one comes from the balanced modulator. So you will get Vc cos omega ct minus Vm into Vc sin omega ct into sin omega mt. This is the output of the FM signal, that is output of the combining network. We know that MF is equal to del F divided by FM, that is modulation index for a FM signal is defined as the ratio of frequency deviation to the maximum frequency. This is the modulation index of FM signal. This is also equal to Vm. So you can replace Vm by Mf. So you will get the final equation as Vfm of t is equal to Vc cos omega ct minus this Vm can be replaced by Mf. So Mf Vc sin omega ct sin omega mt. This is the final FM signal, but it is the NBFM, narrow band frequency modulation. This narrow band frequency modulation signal can be converted into wide band signal using multipliers and amplifiers block as shown in the main block diagram of frequency generation of indirect method of frequency generation of FM signal or the Armstrong method. Thank you.